Enumerated types revisited. In Chapter 3, we introduced enumerated types, which defined a new data type and list all possible values of that type. So here's an enumeration for season. They have winter, spring, summer, fall. Once established, the new type can be used to declare variables. So here they declare a variable named time, and the data type is season, which is the enumeration that was just created up here. The only values this variable can be assigned are the ones established in the enumeration definition. This is actually not entirely true. It can also be set to null because these are actually objects. So any object can be nulled out, meaning it doesn't reference anything in memory. So I'm going to go ahead and demonstrate the seasons enumeration. So the first thing I want to do is I want to create a new project. And then in my new project, in my source folder, I want to create an enumeration. I'm going to go to new, click Java class. I'm going to select enum, and I'm going to name my enumeration. I name my enumeration season. It created the enumeration header for me. And for now, all I need to do is list out the values I want for this enumeration. So when the book created this enumeration, it used all lowercase, but these are actually constant, so they should be in all caps. So once I have an enumeration defined, I need to create a driver class so I can test these. Then we go back to source, right click, Java class. I'm going to make a class called EnumTester. Inside of this class, I'm going to create my main method. Once I have my main method created, I can create a variable that's going to hold a season enumeration. So I'm going to say this variable is going to hold the season. I'm going to create a variable called myFavoriteSeason. Then I want to go ahead and initialize this value by setting it to one of the seasons. So if I just type season and then dot, you can see that IntelliJ is actually giving me recommendations of what to use. It's telling me to use fall, spring, summer, or winter. I'm going to select spring because that is my favorite season. And now what I want to do is output this value. So I'm outputting my value. I'm going to go ahead and compile and run this program. And there's my output. So some other things that you can do with this variable, if you just press dot right after my favorite season, it's giving you some methods that you can call. Now these are all methods that are inherited, but some of the more interesting ones is name, which is just going to be the name of the season, which is going to be spring. Pretty simple. Another one is going to be the ordinal value. The ordinal value is the number associated with that value. So if you go back and look at my seasons enumeration, winter is first, spring second, then summer and fall. So winter has the ordinal value of 0, spring has the ordinal value of 1. So if I were to invoke ordinal on my favorite season, I should expect to see a 1. So I'm going to go ahead and run this program. And here's my output. So the second spring is what we got from the name, and this 1 is what I got from the ordinal value. So that's pretty much it for enumerations as far as the basics are concerned. So this is what we talk about in Java 1. Now just imagine if we created season, well, we use a string. A string can have an infinite amount of results, but there's really only 4 seasons. So when we create this enumeration, we specify the only values that we want. Now I did say that these can be null because these are actually objects. So I can actually set my favorite season to null, and that's one possible value for this. So you kind of have to be careful when using this because you could have a null value for your variable. I went ahead and set my season to null. I'm going to print this out. Now remember, in Java, null means that this reference variable is not pointing anywhere in memory. So enumerations are actually considered to be objects. This is a special kind of class, but we're specifying the only instances of this object that we can have. So I'm basically saying, here's a class for season, but there's only 4 types of instances. There's winter, spring, summer, and fall. And those are my only possible values, but you could still have a null value because this is an object reference variable, and an object reference variable can point to nothing. So null is still a possible value. Another useful method that you can use on enumerations is the values. So values is actually a collection. So if I were to type season and then start typing out values, you can see that IntelliJ is telling you that you're going to get an array of season objects. And we'll talk about arrays in chapter 8, but I can essentially just use a loop and loop through all the possible values of season. So I'm going to go ahead and set that up. So I've set up a loop to iterate through all the possible values. Now this is actually what we call a for each loop in Java. So you have the variable of where you want to store the object from this collection, and then you pass in the collection right here. You have a colon right here. So what's happening is going through this entire collection and pulling out each value and storing it into this object reference variable. And this object reference variable only exists within this loop right here. I put a print line here for some spacing considerations on my prompt. I'm going to print out the name, then the ordinal value, and then I'm going to put a blank line. So I should see this for all 4 seasons. And let's go ahead and run this. And here are my results. It's all winter as 0, spring as 1, summer as 2, fall as 3. This is what we call the for each loop. It's very useful whenever you want to iterate through values of a collection. Now you don't need to use the for each loop. You can do the exact same thing using the for loop the traditional way. And here is the traditional way of writing the for loop. So I declare variable I, which is going to be my index. I set it equal to 0. I say while I is less than the number of values I have in my array. So this right here, what's highlighted is the actual array. So I'm grabbing a reference to the array through season.values, and then I'm getting the length of that. Then for every iteration, I increment I by 1. Then I grab the object at index I, and this is going to start at 0. So the first one is going to be winter. I'm going to store that into the season variable. I'm going to print out all the information. This is going to keep going, right? So this is going to increment to 1 in the next iteration. So then 1 is going to be right here. Then it's going to be spring. And then it's going to keep going over and over until it gets to the end of this length of the array. And then it's going to stop. Now this works exactly like up here. But the for loop up here is a little easier to use because it's made specifically for iterating through collections. I'm going to go ahead and run this, and you can see it does the exact same thing. So here's winter, spring, summer, fall. And here it is again, winter, spring, summer, fall. So these two for loops are doing the exact same thing. An enumerated type definition is a special kind of class. The values of the enumerated type are objects of that type. For example, fall is an object of type season. That is why the following assignment is valid. Time is equal to season.fall. An enumerated type definition can be more interesting than a simple list of values. Because they are like classes, we can add additional instance data and methods. We can define an enum constructor as well. Each value listed for the enumerated type calls the constructor. So here they redid their enumeration and they're passing in a string, and then they have instance data for string. And here's their constructor. In their constructor, they're basically taking in the string that gets passed in, and they're setting it to their instance data. Now, if you look back up here, here's the string they're passing in, December through February, and they're essentially just setting that to that instance data right there. That's what they're doing inside of their constructor. And they have a method called getSpan, and then they test their value. I'm going to go ahead and do this same example. Okay, so here's my enumeration. And one thing I just noticed is if you'll notice that this semicolon is just gray, IntelliJ is trying to tell you that it's not necessary. So I can actually remove that, and there's no syntax error. I'm just so used to putting semicolons at the end of each line that I put it there. In this case, it wasn't really necessary. So I actually need it now because I'm going to come over here and define instance data. So the first thing I want to do is I'm going to go ahead and just copy what they did. So they have instance data for span. So there's my instance data. Now I'm going to go ahead and define a constructor. Now I can do this several ways. I can write this constructor myself, or I can auto-generate it. I'm going to choose the option to auto-generate. So I'm going to right click, generate. I'm going to select constructor, and I want to say I want to take in span, hit OK, and my constructor was automatically created. Now one thing you'll notice, it doesn't have a visibility modifier on the constructor. For enumerations, you don't need it. In fact, I think it's an error if you put it there. I'm going to go and just type it in, and IntelliJ is like upset at me. You see that red squiggly line? It's essentially telling me that it doesn't want it there. So I'm going to go ahead and just delete that off. Now the other thing you'll notice is these are now red. The reason why these are red is because these are actually calling your constructor, and I'm not passing in any string, right? So I'm saying my constructor takes in a string, but I'm not actually passing anything into my constructor whenever I declare these 4 types of data. So these are the only 4 possible objects I can have from season. If this is the only constructor I have, then I need to pass in a string. So I'm going to do this by using parentheses and putting a string inside of here. So now IntelliJ is happy because I'm passing in a string. These strings are actually blank. I'm going to go ahead and just fill in this data with what we have inside of the lecture. So I filled in the data from what we have inside of the lecture. I went ahead and put all of these on separate lines and makes it a little easier to read. Now the next thing we need to do is we need to pass out this span data. So I'm going to go ahead and make a public method that returns a span. Now here's a return method for the span. Now I typed this out myself, but I could have used the auto generate to generate this because it's basically just a getter. So now I'm going to hop back to my enum tester. I'm going to go ahead and comment this out, but inside of this other for loop, I'm going to go ahead and print out my span. And I simply just call the method getSpan that I just created. I'm going to go ahead and run this. And here's the information that was outputted. Winter, that's the ordinal value, and this is a span, December through February. And you have spring, March through May, summer, June through August, fall, September through November. And that's pretty much it. So we were able to actually add instance data to this enumeration and then return that out. So one of the things that I don't like is I don't like that this is printing out in all caps. Now the reason why it's printing out in all caps is because I defined it in all caps. The reason I defined it in all caps is that's the accepted practice for enumerations because these are actually what we call constant objects, meaning that these are constant and should not change. So when you use all caps, that kind of signifies, hey, these values should not actually change. So the method name is actually declared to be final. So if I actually wanted to change this to make it look a little nicer, I'm going to have to make my own method. In other classes, I'll be able to override this name, but I'm going to go ahead and show you that I'm not able to. So if I come back to my enumeration class and I type out the header for the name, you can see that this is all in red. When I highlight over it, it's telling me that name cannot be overridden, that it was declared as final inside of enum. So the enum class made this final, meaning that this cannot be overridden. And we'll talk more about that when we get to chapter 9. So the problem I'm having is I'm wanting to override this name method so that I can make it look a little nicer, but the name method on the enum class is declared as final, so I'm unable to override that method. But what I can do is create a different method that will give me the name that I want. So if I change the method to getName, I'm not overriding the name method, I'm just creating a new method called getName. And all I want to do is I want to return name, but I don't want it in all caps. I only want the first letter in a cap and everything else to be in lowercase. So what I can do is return name, but just return char at 0 as capital and the rest of the name in lowercase. So I'm going to go ahead and do that. And here's what I'm doing to get the name that I want. So I'm finding the first character, I'm leaving it in all caps, and then I'm taking the last of the characters, but I'm taking those to lowercase. Now I need to go ahead and test this method. So in my for loop, I'm going to invoke the method getName, and that's going to return the name that I just created. I'm going to go ahead and run this, and here are my results. So this is the name, but this is me modifying the name, and then there's the ordinal value, the span. You can see that it came out exactly how I wanted it to, where the first letter is capital and the rest is in all lowercase. The idea here is these enumerations are actually classes, so you can actually modify these, add instance data, create new methods, so that you can make these enumerations more useful to you. So we were able to do that by making a span and making a method to get us a nicer looking name. Every enumerated type contains a static method called values. I showed you how to use this, that returns a list of possible values of that type. The list returned from values can be processed using the for each loop. I also demonstrated that. An enumerated type cannot be instantiated outside of its own definition. So what that means is you can't instantiate an instance of that enumerated type. It all has to be within the enumeration. So if I were to come to my driver class and make a new variable to hold a season object, if I try to instantiate the season as a class, like what I'm used to doing with other classes, it's not going to let you. So the only way to get an object of this season class is because it's an enumeration, you have to specify the specific value that you want through the enumeration name. So this is the enumeration name, and then this is the object that I want from that enumeration. A carefully designed enumerated type provides versatile and type-safe mechanism for managing data.